I recently received an email from a company. Actually, I have to say it went into the spam folder automatically. So I was just checking the spam before ditching it. And their email started, sorry to intrude, you might think this looks like spam, and that's probably why it had been flagged as spam. But it turned out not to be spam. It was a company called Isotip who manufacture these cordless soldering irons, and they were offering me a gift of a soldering iron. And I have to say, I don't normally accept gifts because, well, as you know, I tend to take things to bits, and yes, Isotip, I'm going to be taking your iron to bits too, and the charger. And I'm always worried that if I accepted a gift from someone, it'd be really awkward if it turned out to be really crap. So I wasn't keen on accepting their offer initially. And then I went and looked at the irons and I recognised it. I recognised this exact style of bit as an iron I used when I was very young, decades ago. And the one I got was actually a Draper iron. And the one advantage I have to say it had over this was that it had a cap that slid over for protection, a ventilated cap, and that was actually good. This one doesn't have a cap, it's a slight niggle that I've got for using it in an industrial toolkit. Fine for the flight case toolkits though. But the Draper one, that was about the only advantage it had. The Draper ones didn't last that long because they were quite cheaply made, and it turns out the little switch in the Draper, which was a nice clicky switch, this one isn't a clicky switch, this one's a very tough springy switch. Turns out that may have been the weakness in the Draper. But anyway, I recognised it, and while it worked it was very good, the Draper one, so I thought I would like to try one of these out, so here it is. It's called an Isotip. Their website is www.iso-tip.com if you want to check out their stuff. And they have a really staggering array of these bits. Now, the bits are interesting. This thing contains two standard 1.2 volt rechargeable cells. They're NiCad, which is odd. I was expecting nickel metal hydride. I thought, you know, in this day and age they'd have changed the technology, but I think they may have stuck with NiCad because of its maybe preferred current delivery abilities. Because I tried to measure the resistance of one of these bits, and I could not measure it. It was so low that my meters couldn't reliably measure it. So I got my bench power supply and I clipped the leads on, and tried to read it off the bench power supply. That wasn't working either. And then I stuck a meter across the actual legs of it, plus the power supply, and at least got it 5 amps to pass through it and measured the voltage across it to get the actual resistance. The resistance is 0.1 of an ohm. And when you consider, I don't know if that rises with the heat, but when you consider that this thing, when it's operating, I measured the voltage across it, puts about 2.1 volts across this, then that would suggest something like 20 amps at 2.2 volts, so 2.1 volts. So this tip is dissipating 40 watts of heat, and that certainly shows when you're soldering because it really works very well, as I'll show you. Now, these used to be manufactured by Wow Clipper Company. And we all know Wow clippers are pretty good quality. I've got a set of Wow clippers, they're good. And I have to say that these are really well made. Physically, they're very chunky inside. I'll show you that because I'm going to take it to bits. You'll also notice it's got a tungsten lamp under here. The reason for that is that the design has not changed. The design is pretty much as it was, probably going back to the 1970s. And that even extends to the power supply here, the recharging unit. And I'm guessing that the reason that the design hasn't changed is because ultimately it works really well. And I was thinking maybe they've introduced electronics, but to be honest, the only thing they could really improve on would maybe to replace this with an LED source, the light, but use the little booster circuit for it. But having said that, the little tungsten lamp, for the amount of use it's going to get, it works very well. It's a little bayonet cap tungsten lamp, which is quite odd. I've seen this type of lens lamp available in Edison screw. It's also quite footry to get back in. Oh, very footry to get back in. I might just tweak that round with my long nose pliers because it's quite hard to rotate because it's quite slippery. There it goes. And I guess ultimately, given the amount of use it's going to get, the little tungsten lamp works fine on the 2.4 volts from the cells. So let's say I give this a go. Now, because this is basically heat on demand. You have to hold the button for it to heat up, and ultimately it heats up very quickly indeed. So I've got a little circuit board here. I'll just pop this resistor in here. And certainly, when I had my original Draper one, I used it quite a lot. It was my main iron at the time, just for little hobby projects and stuff like that, because it was convenient that it just heated up on demand. And it takes about 10 to 15 seconds to heat up and produces the same results as you get using a full mains power iron. It's very good, actually. That's what I liked about the other one. You get used to regulating it in the sense that if you're doing stuff, you'll occasionally press the button that just keeps it up to temperature, so you get used to using it in that sense. It certainly beats turning on a mains iron for a quick random solder joint, because it's up to temperature almost instantly. So now I'm going to do an LED in this, just because I might as well build this full circuit. This circuit is actually a little experimental colloidal silver generator. Oh, I'm footering this. And now we'll try the biggest joints in this, which are the terminal block, which are really quite big joints. So they'll test its ability, but given that when you do the maths, and it's about 40 watts that's coming out of this thing, it's more than capable of doing solder joints like this. I might actually use thicker wire for this. Thicker solder, should I say. Am I going to be able to hold this in place? Maybe not. I shall just place it down there. So again, I'll just wait for it to resume its temperature, which happens very quickly. I've been using this for those little rogue jobs, you know, when you have a wire pop off where you're working on something, and then rather than wait for the solder iron to heat up, you just grab this and press the button, and it's hot and ready in no time. So yeah, that's actually handled them perfectly. It's been good with that. So now let's open it. Another thing about this, this has, is this going to be red hot now? It is going to be red hot. I shall quickly tweeze that out and put it over there. This thing has these little spring-loaded, very stiff spring-loaded copper contacts, and when you press the thing in, it suggests putting it at an angle and then pushing down. It kind of levers them back, because obviously there is a lot of current there, 20 amps. But if you're going to use the same bit all the time, this is the high mass bit. Probably the high mass bit would have been even better for the circuit board, because it's large joints. But if you want to use one bit all the time, you can take these screws out, discard the little copper bits or put them to the side, and then you can physically just screw this in permanently. So let's open it. Now I do have to say, having seen the original, I was really quite surprised that, as you'll see, nothing has changed. It's a very, very simple design inside. And it's quite a chunky unit. It's got a lot of weight because ultimately it's mainly battery. So let me see if I can take this to bits without everything exploding to pieces. No, it doesn't explode into pieces, that's good. So the button is captive. It's got one of those little push-on sort of latching washers. And when you press the button, all it's doing is pressing this rigid brass strip against a screw that is basically clamping down one of the battery terminals. This pack here is 2.4 volt, 1300 milliamp hour. That doesn't seem a huge capacity, but it's pretty typical for the NiCads. And as I say, probably the reason they're still using NiCads over nickel metal hydride is that the NiCad is capable of just pumping out tons of current. We're talking 20 amps here. That's a lot of current. So the connection to the tip, there's a very stiff wire coming up here, which passes through the lamp's contact, the lamp holder's contact at the back, And then that wire is sleeved with the fiberglass sleeving, comes up and it bends round and goes onto the battery contact here. The charging contacts in the bottom, which just basically sits down into this charging base, and it's got two spring-load contacts, and it's just these two pins here pressed into a circuit board type material, and they just connect to both ends of the battery. That's it. All these two pins are doing is bring the battery out for charging. This brass strip, it's also quite interesting that it's got a contact, just a section just bent down and touching on the side of the lamp housing, just keeps it very simple. And then after that it's these huge chunky output terminals, so really there's not much to it. It's batteries, this big heavy springy contact, the lamp holder, and then the output terminals, so nice and simple. Not really much to go wrong, and actually quite serviceable. As I say, there's a very good chance that the reason they haven't changed the design is because ultimately there's no need to change the design. It's as functional as it was back in the 70s. And these irons do go back to the 1970s. Kind of refreshing to see something like this still being sold. Another thing worthy of note is it's got this little rest here, and when you place it down the bench, it does hold it. It's very stable, and it sits rock solid and holds the tip off the bench. Now let's take a look at the charger. So bear in mind that to charge it, you just drop it in like this. There's no light or otherwise indication on here, and unfortunately, despite the fact I live in the UK, I'm not sure if they actually do a European or UK one, but this came with a 120 volt base with the American plug in it, which is no great problem because I have a shaver socket which does put out the 110 volts, so I used that to charge it. So in keeping with the retro styling, because this is basically just a product being made in the same style as it always was, it's got this sort of fiberboard in the bottom. Oop. And all the charging circuitry is in this. And it consists of, just as in the old days, you take the fiberboard out, it just feels so retro doing that, it's nice. There's the springy terminals that are going through, and then ultimately it's just a transformer connected to them. There's no circuit board in here, and the transformer is just held in place when you screw the lid on, and it clamps it down onto these two pins. Very simple, very easily manufactured. But MD, who's got the savvy about electronics and so on, will now be saying, well, but it's DC, because that's basically the battery contacts that you're going to there. So this transformer must have maybe a diode in it, and if you measure it, if you use the tester, set to diode, set to measure forward voltage, and you stick it across the contacts in one direction, you don't get anything. Stick it across the other, and you see one diode junction. It's just basically got a silicon diode in series, so ultra simple circuitry. There's no end of charge cutoff. It just charges at a current that's basically decided by this little transformer, which rather amusingly, I think it's still got the WAL name in it. Is it WAL? Yes, it is. It's got WAL printed on it. I wonder if they still manufacture it. Bear in mind that WAL uses wound components in their products, so they may still be manufacturing some of these components. So I have an idea that I may actually want to modify this to be USB powered. So let's sacrifice this little transformer here to see if it does have the little, well, obviously it does have the little diode. Let's see where they've actually put that inside it. It was almost nostalgic taking this to bits because it was so old school, and the fact that it's basically a product that has lasted this long, because, well, it's pretty good actually. As a service technician's soldering iron, it is really handy because, you know, with the gas ones, there's a few issues with the gas soldering irons, and well, one of them is that they tend to be rather random in their output, and they burn stuff in their vicinity with the gas. I mean, sure, they're hot all the time, but they can be quite ferocious at times. The other thing, I had a squirmy moment with a gas soldering iron that I was working a new job, and I dropped it and it almost went down somewhere that I wouldn't have been able to reach it, and there's lots of cardboard and stuff down there. And if I'd dropped the gas iron, it could have actually caused a fire if I'd gone down there. So maybe with this one, if I'd dropped it, it would have, well, I've been a bit disappointed at losing it, but it wouldn't have continued to burn like the gas iron would. So it was safer in that respect. I think I'm getting closer to a diode here. Yep, there's a diode. I'm guessing that the transformer winding will just be going on one end, and this wire's coming off the other end, and it just looks like a typical generic 1 amp diode, which is reasonable enough. Actually, that sticky tape is very sticky. Yep, so it's really just a single diode in series with the transformer between it and the battery. And that's all that's really needed, because with these small transformers, they have what's called a fairly high regulation, which means that the voltage floats up quite high, but when you load them down, it will progressively, as the current goes up, the voltage goes down. So basically, they've chosen the transformer to deliver the charging current via that diode that matches the 2.4 volts of these cells. So yes, I'm going to modify this now. I'm going to make this USB powered, and the reason I'm going to do that is just for the convenience, because it means I don't have to find a 240 volt, 110 volt outlet. So the circuit I'm going to use is probably going to be plus 5 volts. I'm going to use this to do the soldering as well. So this is going to be the plus terminal out to the rechargeable batteries. So that will be the negative. And I'm going to use a diode, a blocking diode, pretty much as this transformer has in it, but just blocking the 5 volts DC. And I'm going to use a resistor to limit the current. Plus I'm also, because bear in mind this is about 2.4 volts, probably going up to about 3 volts tops when it's fully charged. So I'm also going to use a LED here, a red one with a voltage of about 2 volts, and a resistor chosen to limit the current to quite a low level, because all it has to be is an indicator, so I'm aiming for just a few milliamps for that. And that also means that if, in the worst case, if the terminals get shorted or something, it's not going to overload the LED with excess current. Not that they are likely to get shorted. So I'll be right back after I've done this experiment and built it up, and I'll tell you the resulting values. And job done. Red LED included. Place it in, it's now charging and it's running off a 5 volt USB power supply. So I'm certainly not going to beat the simplicity of this. This is just sweet in terms of its simplicity. It's just the transformer and the 1 amp diode in here with the winding wrapped around one end of the diode and the output wire going around the other, and then the other wire just with coupling with the output winding, just like, it's just this. Possibly the first time I've seen a diode incorporated in a transformer like this. Not 100% sure about that. But it's a nice simple solution. And certainly with a high capacity nickel cadmium cells, it's an ideal way to charge them. Just continuous trickle charging. That's why they basically use them in emergency lights. They're ideally suited to that. So the circuitry I used in the end was a 1N4001 diode and a 10 ohm resistor. The 10 ohm resistor was just one I had knocking about. It was out of a LED lamp. And on the other side for the LED, I used a standard red LED because it's got the lower forward voltage of about 2 volts, and I put it in series with the 100 ohm resistor. And I've measured the voltages on 5 volts here, the USB power supply, and the voltage across the 10 ohm resistor is 1.6 volts, which means it's charging the battery to 160 milliamps. And in a way I could have gone lower than that, but 10 ohms is what I had. I may add another 10 ohm in parallel with that later on just to boost the current up a bit. The voltage measured across the 100 ohm resistor is 0.5 volts. That means the LED is passing 5 milliamps and it's charging, which is perfectly acceptable as well. It's perfectly bright for the indication. So yeah, very simple to do really. Everything is just pretty much in the style of the original product, just hardwired, no circuit board. So we've got the positive coming in here from the USB power supply, and it's going to the LED, and it's also going to the diode. The diode then comes up and goes to the 10 ohm resistor and then onto the metal contacts. I should add, I lifted these metal contacts out to solder them just so I didn't damage the plastic, because this iron gets very hot, it's very good. And I did solder these contacts with this iron, and it did it with no problem whatsoever, which is always good. So the 10 ohm resistor is going to the positive battery terminal, and then of course the other end of the LED goes via the 100 ohm resistor to the positive terminal again, and the negative just goes straight onto the battery terminal here. And that's it. So very simple modification to make for making it USB chargeable. And a couple other things I thought about that's worth mentioning about this. The button for safety is lockable, because obviously you don't want to have that pressed in the toolbox, because that tip gets very hot very quickly. So if you turn this to the lock position, it can't be pressed. But when you turn it to the unlock position, then the button can be pressed down and it activates as normal. There's another safety feature in here. Because these terminals are directly connected to the battery pack, there's a bit of fuse wire is one of the connections. And that means that if you accidentally short that out, it's not going to pass lots of current and spark and so on. It's just going to blow that fuse. And so if you've got one of these and it stops taking a charge, then the first thing to suspect is that you may have actually shorted back out and blown that bit of fuse wire. And it is just a bit of fuse wire. A piece of thin copper wire will fix that. So another thing about this that's nice is there's no warranty void if broken type label. They actually encourage you to actually open these up, take the screws out, open it up, change the battery pack if you want, fix that fuse wire if you have that little incident, and it's completely serviceable. Another thing that I've suddenly realised now, my old Draper version of this, often, it would just go flat while you were using it, because I'd just charge it as if you were charging a torch or a flashlight and then use it, when the correct way to use these is just to leave it on charge, on standby all the time. Because if you consider that even with fairly high capacity batteries, this thing draws 20 amps when it's running. So, it's easy to lose track of how long you've been soldering. So the best approach there is just to pop it back into the charger when you're not using it, just so it's always kept topped up ready for action. But yeah, I really like this because it is so retro. It's delightfully retro, and it's just simple, robust and serviceable. It's a really quite a nice little thing actually.